So comparing two proportions. So now we're entering two samples, right? When you do hypothesis tests or confidence intervals on your calculator, right? You have to choose which one of them. Some of them have two proportion, two sample, right? What does that mean? Well, that's what chapter 10 is all about. So what is the difference between one sample and two sample inference? When I say inference, I mean confidence intervals and hypothesis tests. Well, when we're talking about one sample, chapter 7, chapter 8, chapter 9, those are all one sample. We asked this question here. Is our sample significantly different than what is being claimed? Right? If it is significantly different, then we reject. If it's not significantly different, then we fail to reject, right? That's what one sample is. Comparing our sample versus what's claimed, right? The national average, the whatever is being claimed by a company, right? Now we're entering two sample. So what is the difference? Well, now we're given two different samples. Now we're comparing to see if there's a significant difference between each sample, right? If there are two Math 1 classes, let's say you have one class with one teacher and another class with another teacher. Let's say they take a test. We're trying to see if the test results from one class are significantly different than the tests of another class. Which one's higher, which one's lower? Is it significant, right? So that's what we're testing here. We're trying to see if the two samples, all we're comparing is the two samples. The hypothesis will always be the samples are not significantly different. They're the same. Okay? That's our hypothesis. Our hypothesis will always be they're the same. The alternative will be nope, one is significantly higher than the other. Or we don't know if which one's higher. They're not right. Greater than, less than, not equal to. So we're comparing two samples. Are the two given samples significantly different from each other? I'm not just saying different, I'm saying significantly different. Okay? That's why we do things like hypothesis tests and confidence intervals. Okay? Okay, so when do we have two samples? Well, I took this off of your notes from last semester, right? When we created these guys, right? We always got two different things at the end, right? We always said, okay, so we're going to run an experiment. 20 goes this way, 20 goes the other way, and then we're going to compare results. What does compare results mean? It means doing a two sample confidence interval or hypothesis test. So this is what we're doing in this chapter right here. We're not doing the rest. The rest of it we've already done, right? How to get a sample, how to split up the sample. That was all earlier in the chapters. Now we're going to focus on comparing the results. Is treatment 1 significantly better than treatment 2? We don't know. That's what these things will tell us. Okay? So anytime we want to compare two populations versus each other, right? Two populations, Central High School versus Central East High School, Garza versus Central High School, right? We want to compare things, academics, athletics, whatever. That's when we use two sample inference. So the first one is two proportion Z confidence intervals. So today's all proportions, so it's always going to be Z, right? So when we use this to predict or estimate the difference in the population proportions, the difference between the two. Okay? The difference between the true difference in the population proportions. All right? I want to know what percent of students at Central High School versus Garza High School have above a 3.0. right? So I take a sample of students. I take 100 sample at Central. I take 100 sample at Garza. In the Central, 60% of the students in the sample had over a 3.0. In the Garza sample, 45% of the students had above a 3.0. Does that mean Central is a better school than Garza? Now we can mathematically show that we're superior. That's what we can do now. We can show that. We can show that, hey, there's something to this, right? Or was it just that sample? Did I happen to get a good sample of really high level students and a sample of low level students from Garza? Well, we can say now definitively there's a significant difference between the two, right? So that's what we're trying to do today. Okay? So the difference is, well, we still, with confidence intervals, we still have five things, right? 5 steps. The difference is that we have 2 samples. So population parameter, we have 2 populations, right? Population, like for example, in my example I just did, population 1 would be students at Central High School. Population 2 would be students at Garza High School, right? They're 2 separate populations. No one is a student at Central and at Garza, right? They're 2 different populations. Conditions assumptions are the same as in previous chapters. I'm not adding anything. There's still only 3. But remember, we just have to check both samples. So that's going to be a little different. It won't be that much. Interval will be the difference in the proportions. Okay? Okay, so very popular in FRQ section. Very popular in the FRQ section of the AP test. They love 2 sample stuff. They love chapter 10 stuff on the FRQs. Not so much on multiple choice, but FRQs, there's tons and tons of past FRQs that deal with 2 sample. 2 sample means, 2 sample proportions. Okay? Okay, so here we go. Here's our test statistic. It looks ugly. It looks ugly. To some extent, it is ugly, but it's not as bad as you think. It's not as bad as you think. Because here is our formula sheet, right? If you go to the back of the formula sheet and you go to the 2 sample section, we have means on top and we have sample proportions on the bottom. This guy right here is by far the ugly stuff. That's ugly. I'll admit that's ugly, but you don't have to memorize it. You do not have to memorize it. What is the stuff that you do have to memorize? Subtraction, and then plus or minus z critical. That's it. Everything else is on there. So this part right here is on your formula sheet. You always start with subtraction. We always start with subtraction. Sample 1 versus sample 2. Plus or minus, and then z critical. Z critical is what we always do for those guys. The conclusion, we are blank % confident that the true difference, so this one is going to have the word difference in it. We're not going to say true proportion because we're looking at the difference. So we are blank % confident that the true difference proportion is between this and this. Okay, so just including that word difference, that's mainly the difference. Okay. All right. I'm not going to go over tests right now because we'll do that later. I want to do a confidence interval from the beginning to end just to show you how much you guys know how to do already. Okay. So jump ahead to the example where it says patient with lower back pain. Patient with lower back pain. Jump ahead to that one. We'll do this example. Patients with lower back pain. Okay, we'll do this example together. I want to do one of these just to show you. It's like, oh yeah, I've done that. Yeah, I've done that. It's not that bad. Okay, this is not that bad. Chapter 10 is one of the, like I said, faster chapters we go through just because you've done it all. You've done a lot of this stuff in chapter 8, chapter 7, chapter 8, chapter 9. Patients with lower back pain are often given a non-steroidal anti-inflammatory drugs. They're called NSAIDs. Okay? Like naproxen to help ease their pain. Okay? Researchers wondered if taking Valium with naproxen would affect their pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatment groups. So some of them were given naproxen and Valium to treat their lower back pain. And the other group was given naproxen, but no Valium, just a placebo. Okay. After 1 week, 39 of the 57 subjects who took both drugs reported reduced lower back pain, compared with 43 of the 55 subjects in the naproxen and placebo group. Okay, so what we have to do is compare the two samples. There's two samples of people, right? There's 57. So the two samples are 57 and 55. Together they make up 112. Okay? We're not going to compare them. We're not going to mix them together because they were different. They took different drugs. They're two separate samples. Okay, so we have to construct and interpret a 99% confidence interval for the difference in the proportion of patients who would report reduced lower back pain. Okay, that's what we're going to do. It's a confidence interval. We have 5 steps: population parameter, conditions, assumptions, test statistic, calculations, conclusion. Okay. All right, so we have two populations of people. Right, we have two populations of people. So if we're doing population proportion, or sorry, population parameter, we have two populations. We have two samples that reflect two separate populations. We have the sample who took both drugs, and we have the sample who took one drug and a placebo. Okay, so we're going to have two proportions. So we'll say P1 for the first group. So just like we would normally, true proportion of people, what'd they do? They took both drugs who took naproxen and Valium to treat lower back pain and felt better. Because everyone took naproxen and Valium, but not everyone felt better. Only 39 of the 57 felt better. Okay. Now, who was the second group? If that was the first group, who was the second group? In other words, what's the difference between the first group and the second group? Okay, so how would I word the second group?
The true proportion of people who took the placebo and naproxen.
Keep going.
To treat the lower back and feel better.
So it sounds like you use a lot of the same words. How many new words did we have? One. So let me show you a way of doing that. You don't have to rewrite the whole thing. You can use quotations. If you're using the same words, you don't have to recreate them. You just fill in the words that I need to change. Instead of Valium, I'm going to put placebo. Now, do you have to do this? No, you can rewrite it. But it's a shorthand method. It's an acceptable shorthand method for having to do that. If you're repeating the same thing, just use quotations.
Does each quotation means one word?
Yes, each quotation means one word. Do you have to use this method? No. But if you don't use this method, I better see true proportion of people who took naproxen and placebo to treat lower back and felt better, right? It's a way to save time. It's an accepted form of shorthand. They won't take off any points. It's accepted. Okay. Next step, conditions, assumptions. All right, so let's set up. It's the same three. It's the same three we've been doing since the beginning of chapter 7. But we have 2 samples. So I need 3 columns. Okay. Conditions. So I'm going to check. This is P1. Check. P2. Okay, first one, SRS. How was the first sample and second sample obtained?
It was stated.
Stated. So over here we put stated like we've always done, and over here we put stated. You're just doing it twice. Next one is 10% condition. Okay. N is less than or equal to 10% of big N. Be careful here. N, there's different N's for each one. The first one, naproxen and Valium, there were 57 people. Naproxen and placebo, there were 55 people. So there's not the same number. Sometimes there won't be the same number in each sample. Sometimes they'll be the same, sometimes they won't be. So this one is 57 is less than or equal to 10% of. This one's 55 is less than or equal to 10% of. So N1 refers to people who took naproxen and Valium. N2 refers to people who took naproxen and placebo. They're 2 separate groups. So these, big N would be all people who took naproxen and Valium. This one would be all people who took naproxen. Really, they just took naproxen, but I'll put placebo and placebo. Okay. Normality. This is proportions. So it's central limit theorem. Sample size will not come into 2 will not be the one we did that's decided. It's these two guys right here. N times P and N times 1 minus P. Okay. N in the first one is 57. What is P? What value do we have for P here? What value do we have for P here? Right? There's no claim because there's one sample, or it's two sample. There's only claims on one sample. So what do we use for P then? P hat. Okay, do we have a P hat? We do, right? We just didn't write them down. We should have done that at the very beginning. We have two P hats. I have P hat 1 and I have P hat 2. P hat 1 refers to the people who took naproxen and Valium. P hat 2 refers to the people who took naproxen and placebo. Naproxen and Valium was 39 out of 57. 39 out of 57. So 39 out of 57. Let's see. Is 0.684. 0.684. And then placebo and naproxen was 43 out of 55. So 43.55, I get 0.782.
How'd you get 82?
43 divided by 55.
Oh, about 42.
Okay. All right, so those are the guys we're going to use. So for the first one, we're going to use 0.684. For the next, let's see, 57, 1 minus 0.684. This is 55 times 0.782. This one is 38.988. That checks out. This one is 18.012. That checks out. Oops, 43.01. And 11.99. Okay. Those are the conditions assumptions. Two more. Okay. Two more steps, or three more steps. Statistic, test statistic. Okay, test statistic. We always start by subtracting the first minus the second. Always subtract first minus the second. That's the first thing we're going to do. And then since it's proportions, it's going to be z critical times. It's written on the board, but I forgot it. Let's say I forgot it. Well, it's right there. It's right on your sheet there. P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2 square root. Okay. So now for calculations, we're going to plug in. The first sample was 0.68. So we have 0.684 minus. The second sample proportion was 782. Plus or minus Z critical. Z critical, this one is a 99% confidence interval. So you could either go to your tables or it's in our notes from the beginning of confidence interval. So 99, Z critical is 2.57. 2.57. Times. Again, we don't have P1, but I do have P hat 1. So I'm going to use P hat 1, 0.684 times 1 minus 0.684 divided by N1. That's the number in the first sample. That's 57. Plus, let's see, P hat 2 was 782. So 0.782 times 1 minus 0.782 over 55. Now, I'm not going to crunch those numbers because it would take me a little bit of time. I'm just going to use the calculator. So let me bring up the calculator. Same place we always go to, stat, scroll over to tests. And then we're going to put our information in for this problem. Okay. So stat, you're going to go over to tests, and then we have our options. Interval, right? This is an interval, so we're looking for the ones that say interval. So we'll start with number 7. We are looking for 2. We want 2, the ones that say 2. So that's either 9 or 0 or B, right? We want letter B, 2 proportion. That's the only one that says proportion. The other ones, 9 and 0, are for when we do means. Okay, so we're going to hit B. X1 and N1 are the fraction for the first sample. So the first sample, P hat 1, was 39 over 57. So we're going to put 39 over 57. 39 is the successes, 7 is the total in the sample. P hat 2 was 43 out of 55. Confidence level was 0.99, pretty high confidence, very high confidence. That's all we need to give. And then we're going to hit calculate. There's no pictures with this one because only pictures with hypothesis tests. So we don't need to draw a picture. We're going to hit calculate. And we're going to write down the first thing. The interval. The interval goes from negative 0.3114 to positive 11623. Okay. So it goes into the negatives. Goes into the negatives because if I subtract them, that's a negative number. Okay. Okay, last step, conclusion. We are blank percent confident that the true difference proportion in is between this and this. We are 99% confident. That the true difference proportion in, what did we subtract? We subtracted people who took both drugs minus people who just took one drug. So we would say true difference proportion in people who took naproxen and Valium versus people who took naproxen and placebo is between negative 0.3114 and 0.11623. Okay, I'll stop right there for a second because that's all fine and dandy, but they're going to ask you questions based off of this. So we really need to understand what this means. Okay? We are 99% confident that the true difference proportion in people who took naproxen and Valium versus the people who took naproxen and placebo is between negative 0.3114 and 11623. What does that mean? Well, my first question would be, does this represent significance? So if I'm a doctor and I have patients with lower back pain, can't even walk, am I going to recommend that they take both pills? Am I going to recommend that say, you know what, am I gonna prescribe them Valium? Valium's a pretty heavy duty drug. If you're a doctor, you only want to prescribe it to people who need it, right? There's a lot of people who abuse Valium. So any of those types of narcotics, they really limit who can get those narcotics. So am I going to write a prescription for someone for naproxen and Valium? Or am I going to say, you know what, the research doesn't show that it helps. I'm not going to give you Valium. Just take naproxen.
They saying that between those two, the effects is not bad.
Well, I'm trying to say, if I'm the doctor, this is what doctors do. How does a doctor know what medicine to give patients? They read what's called medical journals. Medical journals. That's what they do. When they're not seeing patients, they're reading medical journals, right? And they're given research with all of these things in here. With all of these things in here. Here's the little forward. We gave a group of people both drugs, naproxen and Valium, and we gave the other groups naproxen and placebo. This is what happened. So as a doctor, I got to know what that means because my patients rely on me to give them what it means. I want the best treatment for them. So my question is, if I read this, if I'm a doctor and I read this, am I going to give them both and say, yeah, research is pretty solid, I should give you both? Or am I going to say, no, the research isn't good enough, I'm going to fail to reject, so I'm just going to give you naproxen? Which one am I going to do? Let me ask you this question. If there is no difference between the two, if there is no difference between taking both drugs and taking one drug, there's no difference, how would I know that? There's no difference between them. So what this is saying is, if I got everybody who's ever had lower back pain in a room, everyone who's ever had lower back pain in a room, and I gave them both drugs, and then I gave them just naproxen and a placebo, this is the true difference in their pain, or not their pain, but in their how much better they got. Well, if they didn't get better, if both were exactly the same, if both treatments were exactly the same, what would I expect to see? If both treatments were exactly the same, what would I expect to see?
They're exactly the same, but if you just give them the naproxen,
How would I know? How would I know they're the same? There you go, right? Wouldn't it be a difference? That's why I'm highlighting difference, right? There would be a difference of 0, right? There'd be a difference of 0 if they were exactly the same. If each treatment was exactly the same. In other words, I don't have enough. In other words, I fail to reject, right? In other words, there's not enough evidence to show that this one is better than this one, right? So is 0 in my interval? Yeah, it is in my interval, right? So because 0 is in my interval, would I prescribe both to my patient? Or would I say, you know what, the evidence is not solid enough for me to give you that other drug too? Which one would it be? Because I don't have enough information to say that this new treatment, this new cocktail of drugs, naproxen and Valium, is better. How would I know if it was better? What would I expect to see here? Keep going. What would I expect to see here if the new cocktail of drugs was better than the old? What would I expect to see? 0 not only doesn't, but both of these numbers are positive. They're bigger than 0. If they were both bigger than 0, that means the first number is overwhelmingly bigger than the second number. Doesn't the first number represent the new treatment? And the second number represents the old treatment, right? So I would need the first treatment to be overwhelmingly bigger than the second treatment. In other words, a positive number. There's a lot of negative there. And anytime you mix negatives and positives, you're going to get 0, right? So if I were a doctor who's doing their job the correct way, who's looking out for my patient's well-being, I would say, you know what? The research isn't good enough. The research is not good enough to give you both drugs. I don't think it would do you any harm, but I'm not going to even give you the other drug because it's not going to help. The research is pretty clear. It's not going to help. It's happened before. My doctor has said the same thing. When I go in there with when I go in there with a sinus infection or whatever, my doctor will be like, you know what, you should do this, you should do this. Probably not do that. The research isn't clear on that, give me all my options, right? That's what a good doctor does, give you all your options, right? If based on the research they do. That's what doctors do. When they're not seeing patients, they're reading about new things to give you, right? Anytime a new study comes out, they read it and they say, oh, if I have a patient with lower back pain, should I give them this? No, it's not worth my time. It's not worth their time to take both. And Valium, like I said, Valium is a drug it's a narcotic, that it's a sedative, and it's a possibility of people abusing it. Not to say everyone will, but there is a possibility. So anytime with drugs like that, doctors don't like to prescribe that unless it's absolutely necessary to prescribe those things, because they don't want the chances that somebody becomes addicted to it or somebody misuses it. So if they need to give you something like that, they will, but only if they need to, only if the evidence is solid in that direction. Okay? Because they're going to ask you questions like that. Next question, part B. If you were a doctor, would you prescribe it to your patient? Is the research solid enough? No. Because 0 is inside my interval, the research is not, there's not enough evidence to show that this new cocktail of drugs, naproxen and Valium, is overwhelmingly better than just giving them naproxen. Okay? That's what you would do. That's, in fact, that's part B right there, right? Answer that question if you haven't already. There is not enough evidence to show that naproxen and Valium is more effective at relieving back pain than just naproxen. So if I just, let me highlight this. So the orange part, if I just put the orange part, because I'll get a lot of this, I'll get a lot of just the orange part. That's an opinion. That is 100% an opinion. Why do I know it's an opinion? Because there's no justification. How do I know there is not enough evidence, right? This is the part that's needed. It's not my opinion because 0 is not within the confidence interval. That's a fact, right? That's a fact. The orange part is just an opinion unless you have the yellow part. So each of them are both important. The orange part answers the question. The 0 part is justification, because without justification, it's just an opinion, right? It's just an opinion. Like if I gave you back a test, if I gave you back your test and I said you got a 60% on the test, I have to have justification, right? I have to go through it and you have to see how I got that, right? So anytime I have students that don't justify, I'm like, well, how would you like if on your next test, I just gave you a 60% and said, that's it, take that, right? You wouldn't like it, right? It wouldn't make sense because there's no justification. That's like putting that question. But I get a lot of students who don't put the yellow part, okay? Always answer the question with justification, right? Why are you saying that there's not enough evidence? Because 0 is in the interval. If 0 wasn't in the interval and there was all positives, then there's no chance that then there would be no chance that the treatments work the same. But because 0 is in the interval, there's a good chance that both treatments work the same. Okay? So just be careful with that. These are the types of questions they love to show on FRQs. Okay, and then they'll always follow it up with, "Did you understand what you just did?" type question. That's what this is. because a lot of students can do the calculations and the 5 steps. You know, you're pre-programmed to do that. You guys do a great job of all 5 steps, but a lot of times they throw in a part B like this to say, did you really understand what you just did? If you can, if you answer this, but you know, so that's why they'll always do something like that. Okay, you guys have seen that on tests, quizzes, homework, stuff like that. Okay, that's confidence intervals. Tomorrow we will do hypothesis tests, but essentially it's the same stuff, just different formula. That's really all it is. Okay. All right. We'll stop there for today since we only got about 5 minutes left. All right.